Hello and welcome to this retail customer related demonstration showing the instant streaming insight into its financial losses attributed to specific products from various suppliers. The faster these situations can be identified and isolated, losses can be minimized, and the company's procurement department can be quickly engaged to renegotiate more profitable product price points. This entire application solution, built using an intuitive user experience tooling from the industry-leading Oracle Stream Analytics platform, powered by a Spark streaming and Kafka messaging runtime. Let's kick things off by logging into the product, the Stream Explorer tooling, and take a look at our configuration system settings for the Spark, Kafka, and the Visual Analytics components. Now for this application, we have some foundational artifacts that will be utilized. The streaming source of the product's transactional events, the Kafka topic target for the determined and created event results that can be immediately processed by the procurement management applications or processes, an underlying connection, and finally a reference to a specific database table which provides much more information context for the specific supplier. Now we will go ahead and build the solution application, providing a name, useful description, tags for searching artifacts later in the catalog, and we select the initial base streaming source. Pressing the Save button initiates the creation of a Spark streaming application that will receive the event messages and display on the canvas in the Live Output Stream section. Here we can see on the console that the Spark application has been dynamically created and is executing in a draft state, indicating more capabilities will be added before it is ready for production. So let's include more capabilities by creating a new query stage in this application pipeline. We provide a name and description, then save to have this stage added to our application. As the Live Output Stream section on the canvas receives the process events from the previous stage, we now want to add more context to the stream by joining or correlating with a persisted database table using its previously defined reference from our catalog. Specifying the source correlation properties, now instantly the stream and the related table information is joined together, providing much more valuable information for later decision making by the application. We now add a new query stage in the application pipeline in which we will make use of the integrated function expression builder features available in the user experience to calculate the transaction costs, the revenue, and the associated profit and loss amounts. All valuable new information that can be leveraged later in this application. Here we specify the required mathematical calculations and use the rounding capabilities. As each new live output stream column is created, it is renamed to indicate its purpose, and the column view manipulated for better readability. Notice how the tooling provides help by introducing name completion for the available columns. We now want to specifically identify the losses discovered in the streaming data, so we add a new application stage and implement filtering to only show events that have negative amounts. We once again use the expression builder to now provide an absolute value for that profit loss amount, and then we remove unwanted columns. Finally, for our visual analytics features used later in the application development, we need a transaction time, so we add that system time and convert the value as needed. Now we have all the core data elements required by this application. We will send the required columns from the resultant live output stream event shape shown to its target for distribution and management by a listening procurement system. We ensure all required columns are correctly mapped so that the live output shape stream shows the information required. Note here that until the application is finally published, no output events will be sent to the relevant Kafka target topic. Okay, so now that is all completed, we will add some more visual representations in the application pipeline on our losses only stage. By selecting the Visualization tab, we can define various charts that provide a richer visual experience and help to identify situations from a real-time operational perspective. For now, we will select a bar chart and apply the required attributes. As the new streaming data flows through the application pipeline, the graphical image builds for immediate situation awareness of the offending products and suppliers. Once verified, the application can now be formally published to the Spark streaming runtime. Here again on the console, we can see the application is now executing in a public state and will continue to provide permanently the streaming analytics with the results passed to the target Kafka topic for downstream processing. Now we will implement both real-time streaming and historical visual analytics by creating a cube. Note that a cube is a method of storing data in a multi-dimensional form with its data measures categorized by various dimensions. Once the cube is created, data is flowed by the streaming application into the cube for further analysis. By selecting the cube artifact, it will provide features which we can now use to create the visualization slices that will be subsequently laid onto an interactive dashboard. We create a big number value indicating the total loss count until now. By using the group by selective features, we can create a table view and then subsequently a bar chart representation of accumulated losses by each supplier. Accumulated losses by channel can also be represented in a pie chart view. All of these charts saved for later use in our new dashboard. Finally, we can create a more exotic bar chart view using metrics with a deeper breakdown showing losses by channel and then by country. Now we have all the visual slices needed for our dashboard. we return to the catalog and create a new dashboard artifact with a name and associated URL. Using the Save button, the dashboard artifact is created, and by selecting, we are provided with the dashboard canvas on which we can add the required slices, define an automatic refreshing period for the visual components, and finally save the dashboard and copy its URL for use by other browser users and applications. So there we have it, a complete end-to-end retail supplier analysis application built not in weeks or days, but in minutes.